Hi Team Kelly, this is lesson 7.9, generating and identifying patterns. Please get that and the date written in your notebook. Pause the video while you do that and then come back once you're done. Okay, so this is going to take a little bit of you imagining that these were really well done arrays. I know they're a little off kilter, but imagine that they're really done. So you can see there that there is a 1 by 2 and a 1 by 2 and a 2 by 3 and a 3 by 4. So what patterns do you notice? Do a quick sketch of these in your notebook and then write down the patterns that you notice, and when you have that done, come back to the video. Okay, so hopefully you would be able to say, well, those arrays are all rectangles. Maybe you would be able to say each array has an even number of cubes. Maybe you notice that. Each array, as you go from this one to this one to this one, each array adds one row and one column. So if I go from this here, I'm adding another row and another column. Okay, if I go from this to this one, so it would be, you can see this shape in there, right? That rectangle. But I added to it another row and another column. So maybe you notice that. If not, you want to write these three things down in your notes because they're very important to your understanding of following the patterns and noticing the patterns. So hopefully you'll be able to know that these arrays are models for the first three rectangular numbers. Rectangular numbers are numbers that can be represented by rectangular arrays, and each successive, meaning the next one, each successive rectangular number, the number of rows and columns increases by 1. This is always going to be true, not just something you noticed in these three, but as you continue to go up in rectangular arrays and rectangular numbers, you'll always find this to be true, okay? It's like a rule. So square numbers can also be modeled by shapes. Can you name the first 5 square numbers? Not rectangular ones, but square ones. Think about that, write down your thoughts on that, and then come back. All right, well, hopefully you know that the first 5 square numbers would be 1, 4, 9, 16, and 25, okay? And I modeled some of those for you here, 1, 4, 9, 25. I didn't get the 16 in the picture, sorry about that, but you can see the concept here. So what rule can we use to find any square number? Give that some thinking, jot down your thoughts, and then come on back. Alright, so hopefully you know that for any square number, I can multiply the number by itself. 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16, 5 times 5 is 25. Hopefully you know this to be true. And then the patterns that you might see when you look at the list of square numbers, well, they alternate between odd and even, odd, even, odd, even, odd. What's this one going to be? Yep, you're right, even, right? 6 times 6 is 36. 36 would be an even number. So we can say that they alternate. Each square number increases by the next odd number. So for example, 1 plus 3 is 4. 4 plus 5 is 9. 9 plus 7 is 16. So that's what I'm telling you here. So notice that when I say it's increasing by the next odd number, so 3, 5, 7, what would the next one be? 9, correct? Right. So 16 plus 9 is going to give you the 25, right? So if we added, so that one was 9, and we added another, it would be 11, right? Well, 25 plus 11 is 36. That's the pattern I'm hoping you can see here. If this is confusing, Go back and rewatch it, slow down your thinking, take some good notes for yourself. It's going to be very important as you go forward in this lesson. Okay, so just as square numbers can be generated by using a rule, so can rectangular numbers. Many patterns can be seen as well. So to help you get started on that thinking, what multiplication equations, now notice I said multiplication equations, can we write to represent these rectangular numbers? So draw these in your notebook, or if you have space up where you drew them already, jot down underneath it a multiplication equation that would represent it. All right? After you have that done, come on back. Hopefully you could have written these multiplication equations. 1 times 2 does equal 2. That's what is represented here. 2 times 3 equals 6. 3 times 4 equals 12. Okay, so we have that down. Now think about this. What patterns can you see in these equations? What patterns can you see? Okay? So hopefully you can consider this. The factors for each rectangular number are 2 counting numbers in order, 1 and 2, 2 and 3, 3 and 4, right? So for example, the factors in the first rectangular, oh, that's what I just went over with you up here, right? Okay, so if we follow that pattern, that I'm going to do 2 counting numbers in order, if we follow that pattern, what equation could we use to find the 4th rectangular number? How about the 5th rectangular number? Think this through. Write those down. When you think you have it, come on back. Well, hopefully you would tell me for the 4th rectangular, I'm going to do 4 plus the next counting number, or multiplied by the next counting number of 5. And for the 5th one, 5 and the next counting number times 6 equals 30. It's really a good pattern to notice in these rectangular arrays. So now I'm looking for an addition equation that you can write for these models. Notice on purpose that it isn't just that I wasn't good at making my arrays, but on purpose now I've left a little space here on each of these. So now I'm looking for an addition equation that would represent this, okay? Write that out beside these, sketch these for yourself, and then write that out beside it. And when you have that done, come on back. Hopefully you could say, well, 1 plus 1 equals 2, 4 plus 2 equals 6, 9 plus 3 is 12, 16 plus 4 is 20. All right, hopefully you got that. Now, to think on this, what do you notice about the first addend in each equation? The first addend, what do you notice about these? And how does this show in the arrangement of each array? How I arranged these with the gap where I did. Okay, think on these 2 questions. Jot yourself some notes. When you have it, come on back. So that's the first addend. Notice that they are square numbers, right? 1, 4, 9, 16. Those are the first 4 square numbers that we listed. And then how does this show? Well, notice that the figure on the left is a square. If I did it really well, you could see these are squares, right? And then the other is a single column. What else can we notice? What else? Think on that. Jot some notes. Come on back. So hopefully you would notice that the sides of the square are the same number of cubes as the single column. So the sides of the square, 2 by 2, is the same as 2. 3 by 3, there's 3 in that one. 4 by 4, and there's 4 in the single column. So hopefully you got that. Then how about this one? The first number, the square, is the second number, the column, the single column, times itself. So for example, in the equation for 12, 9 plus 3 equals 12. So the 9 is this number times itself. 3 times 3 is 9. 2 times 2 is 4. 4 times 4 is 16. Okay, keep that in mind. You really need to let your brain think on that. Using this pattern that you see here, what equation can we write to find the sixth rectangular number? We've got 4 here. How can I use the pattern to help me figure out the sixth one? I would have this written in my notebook, and then I would use that to help me with this. You give that your best shot, and when you think you have it, come on back and check it out. Hopefully you said, well, I'm following this pattern, so I know I'm going to have a 6 here, and this is going to be times itself, right? So 6 times 6 is 36, plus 6 equals 42, right? 36 is a square number, 6 times 6, so that follows into that pattern. The 6 is what I was talking about because I wanted the sixth one, equals 42. So I could use this pattern then to do all sorts of these, right? Okay. So you're going to work on pages 252 and 253. Make sure you read the top of page 253 really carefully before trying to complete problem number 4. All right? Give those your best effort when you think you have them. Come back and check the answers, making sure to correct them in pen so we can talk about them. All right, I know this is tough stuff, guys, so make sure you watch the video over again if you need it. Make sure your notes are really strong. All right, I hope you have a great night. Come on back and check the answers when you're ready. And there are the answers. All right, we will talk about them in class. Thanks.